So in terms of log equations, there's basically two things that you want to do. So when your equation involves a log, you more or less want to achieve one of two situations. You want to get the expression on one side, so you had, log base x, log base a of something is equal to, something else. So you want to get just this one log expression, because then you can just change it to an exponential expression, and 9 out of 10 times you can solve it that way. Another thing that you can do is get a log equaling another log. So if you have a log of one base equaling a log of the same base, then their arguments are equal to one another. So these are the two situations that you want to try to achieve when solving a log equation. So let's try a couple different examples, and we'll practice kind of being able to decide when to do what. So of course we'll start with simple, and then we'll get to more difficult. So that first example on the bottom of page 215 just says solve, and you're given log base 3 of 3x minus 2 is equal to 2. Okay, so we have the first of the two situations that I just mentioned. I have a log expression equaling a number, so the easiest thing to do is to just change it to an exponential expression and solve. So this is just 9 is equal to 3x minus 2. I can add 2 to both sides, so 3x is equal to 11, and x is equal to 11 over 3. Now, you have to always check your solutions with log equations. We'll run through some of the checks. I won't run through all of them just because I don't think we have the time. But if I'm going to go ahead, we'll go ahead and check this one and sub in 11 over 3 for x. Remember, this has to be positive. So we have log base 3, the 3's would cancel here, so that's just 11 minus 2, which is 9. So this I end up with 3 squared equals 9, and my solution checks, so that's good. Okay, so let's go on to the next page. And you can see again a simple equation where the second of the two situations is achieved. So if we have, let's see, this one says negative 2 log base 4 of x is equal to log base 4 of 9. Okay, first thing, you just want, again, a log equaling a log. So if you have a number out front, a coefficient, let's bring that up as an exponent. So this is log base 4 of x to the negative 2 is equal to log base 4 of 9. Now I can say x to the negative 2 is equal to 9. Again, we have logs with the same base equaling to one another, so I can set those arguments equal to one another. Okay, so now I have x to the negative 2 is equal to 9. A couple different ways we can go about solving this. It depends on what you recall from previous chapters. For one, what does this mean? This means 1 over x squared is equal to 9. Anytime I'm solving a rational equation, I multiply both sides by the common denominator. So this will just give me 1 is equal to 9x squared. So x squared is equal to 1 over 9. And so x is equal to plus or minus 1 over 3. Taking the square root of both sides. So that means you have two solutions to check. So I need to check x equals 1/3 as well as x equals negative 1/3. And I'm going to leave the check up to you. Just by eyeballing this right now, if I plug a negative in here, that negative 1/3, that does not make sense. I can't have a negative number here. So just by eyeballing it and not even going through a thorough check, I can see I need to take that one out. Okay. Now, of course, some of these will get more complicated. So let's jump to one that's a little bit more complicated. I'm going to skip the examples on the sheet because I think they're a little bit too easy, and I'd rather do something a little bit more like the ones you'll see on the MyLabs Plus. So let's look at log base 8 of x plus 6 equals 1 minus log base 8 of x plus 4. Okay, so again, you want to keep those two situations in mind. Can I get this so I just have a log expression equaling a number, or so I can get a log of the same base, a log equaling a log, we have the same base. So we can see we have base 8, but this 1 is what's throwing it off. So since I have a constant in the equation, I'm going to get the log expressions on one side, see if I can use properties of logs to combine them, and then I'll just have one log expression equaling another. So I'm going to take this guy to the other side by adding log base 8 of x plus 4 to both sides. So that would give me log base 8 of x plus 6, excuse me, plus log base 8 of x plus 4 is equal to 1. So again, I added this expression to both sides. So now using properties of logs, I can write this as 1 log of base 8 and then multiply the x plus 16, or that's not a 16, that's just a plus. Multiply the x plus 6 and the x plus 4. So now I've achieved one expression equaling a number, so I can change this to an exponential expression. So 8 to the 1 is equal to x plus 6 times x plus 4. Okay, so now I'm down to stuff that we already know. I'm going to multiply this out. And let's subtract 8. Remember, this is a quadratic equation, so I need to set it equal to 0. So 0 is equal to x squared plus 10x, and then 24 minus 8 is equal to 16. Okay, so I'm going to go ahead and factor this and use 8 and 10, because 8 times 2 equals 10, and 8 times 2 equals 16. And so I get two values, x equals negative 2 and x equals negative 8. Now I need to go back up to the original equation to perform my check. Because remember, I cannot apply a log to a negative number. So let's at least walk through one of the checks, and I may leave the other one for you to do. So let's do the negative 2. So this would be negative 2 plus 6 is equal to 1 minus log base 8 of negative 2 plus 4. So this is log base 8 of 4 is equal to 1 minus. Alright, so let's add log base 8 of 2 to both sides. So we would have log base 8 of 4 plus log base 8 of 2 is equal to 1. So this would give me log base 8 of 4 times 2, or 8, is equal to 1, and that checks. Now I can see right off the bat when I plug in the negative 8 that I will have a negative number here and a negative number here. So that definitely will not work. So I only have one solution, and that is x equals negative 2. Alright, let's go on to exponential equations.